So in today's class, we are going to study about tautomerism. Right. So generally, tautomerism is one type of isomerism. Okay. So here, this tautomerism, what happened? This tautomerism is total three types of tautomerism is there, which is actually this topic is one of the important topic for your NEET examination. I think last 2 years continuously they have repeated the question on tautomerism. Okay. So generally, this tautomerism is there are total three categories of tautomerism. Okay. One is keto-enol tautomerism. Okay, and the next one is imine and enamine tautomerism. Okay, keto enol tautomerism, imine and enamine tautomerism, and the last one is nothing but nitro and aciform. Nitro and aciform tautomerism. Okay, so let us try to understand. In this class we study questions related to what tautomerism. Let us start with the first one. So the first category is nothing but what keto-enol tautomerism. Okay, so let us try to understand here the first one. So the first category is keto-enol tautomerism. Okay, so I'm not going to go with the detail like the definition, everything. Just we are going to discuss the concepts. Okay, so first of all, what is the meaning of enol? Enol indicates what? OH group. Okay, keto indicates what here? Generally, actually, it doesn't mean that is a ketone functional group. Here, keto indicates what? C double bond O group. Okay, so this tautomerism between these two groups is called keto-enol tautomerism. Okay, now the thing is that what is the condition to, so like under which condition you can say that the given question is will show keto-enol tautomerism. So what is that condition? The first condition is nothing but, so whenever you see this C double bond O, okay, so this C double bond O must be what? It may be aldehyde or it may be keto. Okay, right. So now what happened here in this case? The C double bond O must have alpha hydrogen. It must have alpha hydrogen. In some cases, in some cases, you should have para hydrogen. So let us try to understand now what is the meaning of this para hydrogen, everything. Okay. First of all, I'm going to write few examples and you people have to answer, like we people will discuss whether it is eligible, like I mean to say whether they are eligible for keto-enol tautomerism or not. Okay. So let us take the first example. So in the first example, what I'm going to do, I'm going to take carbon, carbon, C double bond O, C. Okay. So first of all, let me explain you what is the meaning of alpha hydrogen. Okay. Can I say this is our functional group, right? So this is our main functional group. Okay. Or else I will take this term out below. Okay. Right. It's exactly next position is what? Alpha. Here also exactly next position alpha. After the alpha, the next position we should call it as what? Beta. Okay. Now I didn't written here hydrogen doesn't mean that there are no hydrogens. You have to count the number of hydrogens. So here generally there are total how many hydrogen for this carbon? 3 hydrogens, right? Here also 2 hydrogens and here you will get 3 hydrogens. So do you have alpha hydrogens? Yes. So first of all, it is a aldehyde or ketone. Okay, whether it is aldehyde or ketone means you will call it as this is a ketone, right? Next one. What is the second condition? Do you have alpha hydrogen? Yes, there is a alpha hydrogen. That means this is going to show what? Keto-enol tautomerism. Okay, right. Let us go for the next one. Second example. So in the second example, I'm going to take this compound, right? Right. So first of all, let us try to understand here. Do you have C double bond O? First of all, the first condition is what? We have to check whether the given is a aldehyde or keto. Okay. So can you say the given question is a aldehyde? Yes, but not the ketone. Next, what is the second condition you have to do? Check that whether there is a alpha hydrogen or not. Okay. Now, how to check this alpha hydrogens? Okay. Can I say this is nothing but our C double bond O carbons? Okay. Exactly. Next position is what? Alpha. Next position is what? Beta. Okay. Right. So now what people are going to get here? It's next position. This is nothing but CH2. Here you will get CH3. Okay. Right. So do you have alpha hydrogens here? Yes. That indicates what the given question will show what? Keto-enol tautomerism. Okay. Right. Moving to the next one. Third example. Let us take one third example. So in the third example, I'm going to take C double bond O, OH. Okay, so let us try to understand here, right? Can I say this is the first step is what you have to check whether the given is a aldehyde or ketone. Okay, so can I say there is it's not an aldehyde, it's not a ketone, right? Next, what you have to do, check whether it does have a alpha hydrogen or not. Okay, now what happened, can see C double bond is a standard one, right? So now what happens, next position is alpha, next position is beta, right? So now total how many hydrogens you have? Two hydrogens. Next one is what? Three hydrogens. Okay, can say alpha hydrogen is present, but since the first condition is not satisfied, hence the compound will never show what? Keto-enol tautomerism. Only which functional group will show keto-enol tautomerism? Only aldehydes and ketones. Though it has the alpha hydrogen, but is not going to show the keto-enol. The reason behind this is what? The reason is that there is no satisfied functional group. Okay, right, move to the next one, fourth one. So in case of fourth one, let me take one small example. Okay, here R indicates what? Any functional group. Okay, so let us check whether it's possible or not. First of all, you have to check the functional group. Which functional groups are eligible? Aldehyde and ketones are eligible. Next, what you have to do, check the whether you have the alpha hydrogen or not. First of all, it is a which functional group? Can I say this is nothing but C double bond O system, right? So there is no hydrogens on any side, so hence the is what? Keto functional group. Okay, it's not an aldehyde. Next, do you have anywhere alpha hydrogen? Can say this is our system, right? Next one is acting as what? Alpha, alpha. This is what? Beta, beta, and this is what? Gamma. So do you have anywhere to this carbon? Is there any hydrogen? No, that means there is no alpha hydrogen, though it is aldehyde ketone, but it is not going to show the keto-enol tautomerism. The reason behind this is what? Absence of the alpha hydrogen. Clear till here? Right, so moving to the next one. So this is what? Eligible criteria for what? Aldehyde, sorry, what you can say here? Keto-enol tautomerism. Okay, I hope you people understood here. Right, so now let us try to understand what is the exact process, what process, what happens in the keto-enol tautomerism. Okay, let us try to understand what happens in the process. Okay, for example, if I take this compound C double bond O, C, can say this is a ketone, right? And can say this is our C double bond O system, right? Now what happened, this is alpha and this is alpha. So can I say, do you have to alpha hydrogens are also eligible here, right? So for this carbon, what I'm going to do, for more understanding purpose, I will just elaborate the structure, right? Now what happened in keto-enol tautomerism, what is the thing you people are going to see, that both are in which nature? Both are dynamic equilibrium, right? Now what happened here, so one of the hydrogen here, okay, one of the hydrogen is broken, okay, and here what happened, this bond, whatever the bond is there, okay, let me explain you again. Whatever this bond is there, it is going to shift here. Okay, now if the bond is going to shift here, now the carbon has total, this star carbon has how many bonds? 1 2 3 4 5. Okay, so total how many bonds you have? Five bonds. But if there is a five bonds, can the carbon can form only four bonds. Now anyway, one bond has to be broken because carbon with five bonds is highly unstable. Okay, now which bond is very easy to break? Sigma bond is easy to break, or pi bond? Obviously pi bond is easy to break. Why? Because pi bond is the weak bond. Now what happened, there is one sigma bond and there is one pi bond. Now what happened, this pi bond is going to shift here. Okay, and you are going to get which charge here? Negative charge. Okay, now this whatever this H plus is there, okay, after this hydrogen will come outside, it will get H plus, and this H plus is going to come here. So what is the own differences you people have seen here? Carbon, 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 oxygen. So what is a new thing you people have seen? There is a formation of double bond, right? So what happened here, there is a formation of double bond, and here you can see the hydrogen. So this is the process which is happening in what? Keto-enol tautomerism. Okay, here in double bond is there, so we are calling it as a in. OH group is there, so we are calling it as what? Ol. Okay, so this is which form? Generally you should call it as what? Keto forms. Okay, so out of two, which one is a more stable? Always remember, keto form is more stable than enol form. Okay, keto form is more stable than the enol form. Okay, now let us try to understand the trick. Okay, just by seeing the question, how to write down the enol form. No need of keeping any arrow marks. Okay, so what you people have to do, so wait, so what is the trick you people have to do? So the trick is nothing but whenever you have C double bond O, Okay, so this is a compound. So what you people have to do, can I say this is our standard form? Okay, so to this standard form, the standard form get converted to what? Double bond O is converted to what? OH, and here you people are going to get one double bond. So this is a change you people are going to see. What is a before and after change? Before there was a single bond, here you people are going to get the double bond. Okay, before there was double bond O, now you people are going to get what? OH. Clear till here? Now let us try to write quickly. This is nothing but keto form. Okay, this is nothing but what? Enol form. Okay, let us try to write a few examples. The first example, C double bond O, C. Since it is a eligible compound, I hope you people understood how to find out the eligibility, right? What will be its enol form? First of all, you have to choose the system. Can I say this is our system, right? So after changes, what happened? The system will get converted into OH group, and the alpha carbon, whatever the alpha you people are choosing, no, there you people are going to get one double bond. Clear till here? So this is nothing but what? Keto form. This is nothing but enol form. Okay, right. Move to the next one. Who is more stable? Always remember keto form is more stable than enol form. Okay, next second compound, C is C double bond O H. Okay, this is aldehyde and it's eligible because given functional group is a aldehyde and there is a alpha carbon also. Okay, can I say this is our system now, right? So immediately after enol, this is which form? Keto form. Okay, right. Keto doesn't mean that it's a ketone functional group. Okay, right. Keto form indicates what here? C double bond O system. Right. Now what happened here? Immediately how to convert into enol form? In enol form, what happened? The system get what? The system will get OH group. Right. Whatever the system you people are writing here, the system will get OH group. And wherever you're seeing, whatever the alpha carbon you're seeing, no, there you will get what? Double bond. Clear till here? Always remember keto form is more stable than what? Enol form. Okay. Let us go for the third example. So in the third example, I'm going to take carbon, carbon, double bond O, H. Here what I'm going to write? Chlorine, chlorine and chlorine. Okay, right. So now what happened here? First of all, let's check whether it is eligible or not eligible. Okay, so first of all, yes, Nana, here I'm not every time I'm not discussing the eligibility, but the first step you have to do, always check whether the given question is eligible or not, then you can proceed for the trick. Okay, right. So what is the first one? We have to check functional group, that whether they have provided aldehyde or ketone. Okay, can say they have provided C double bond OH, means can I say they have provided aldehyde, right? Second step is what? You have to check whether the alpha hydrogen is there or not. Okay, right. Can I say there is no alpha hydrogen because at alpha position all the three are what? Chlorines. Okay, that means for the given question you cannot draw what? Enol form. Okay, you cannot draw the enol form. Okay, let's go next one with the fourth step. Fourth question, right? In the fourth question, what I'm going to do, I'm going to start with some cyclic structures. Okay, double bond O. Okay, so first of all, given is a aldehyde or ketone, which is a system. Can say this one is acting as a system, right? This one is alpha, this one is alpha. Okay, whenever I don't write anything, just check whether there is a hydrogen or not. Okay, here total how many hydrogens here? Since the carbon is surrounded by two bonds, generally carbon can form total how many bonds? Four bonds, right? So here the carbon, the pink color carbon has only two bonds. So remaining how many bonds are required? Two. So that's why we are going to write, we are going to write two hydrogens. Okay, here also we are going to write two hydrogens. Here this carbon is also surrounded by two bonds, means this carbon also having what? Two hydrogens. Okay, here also we have the hydrogen, and here also we have what? Hydrogens. Okay, so let us say given is a aldehyde or ketone. Do you have alpha hydrogen? Yes. Then is it ready to show the ketoenol tautomerism? Yes. Right. Now what you people are going to get here? And one more thing, Nana, here stability. Okay, since which one is more stable? Keto form is more stable. So you have to use the arrow mark like this. Okay, so whenever, suppose if you write any theory exams like that, so always remember, use this symbol. What does this long arrow indicates? That the keto form is more stable. So reaction is more interested to convert into which form? Keto form. Okay, next we have to write the enol form. What is the shortcut? Suppose if I am choosing there is a alpha carbon, B alpha carbon. Okay, suppose I want to choose A alpha carbon. Okay, then what will be the enol form? What happens in enol form? The system get converted to what? OH. So what you have to write here? OH group. And since I am choosing A alpha, so you will get double bond here. Clear till here? So this is nothing but what? Enol form. I hope you people understood this fourth question. Right, let us go with the next one. Fifth question. Right. So coming to the fifth question, in the fifth question, what I'm going to do, I'm going to take like this. Okay. Here double bond O. Okay. Here there are two carbons. Here there is one carbon and there is one hydrogen. Okay. First of all, check the given is a keto group. The given functional group is what? Ketone functional group. Do you have at least one alpha hydrogen? Yes, there is one alpha hydrogen. That means, is it ready to show? Yes, this one is ready to show what? Enol form. If it is showing enol form, then which carbon is eligible for enol form? A carbon. This, okay. So this is our A carbon and this is our B carbon. Which carbon is eligible to show tautomerism? Only B carbon is eligible, not the AJ, A1. Why? Because A doesn't have any alpha hydrogen. So if B is eligible, then the structure looks like what? So how does the structure changes? The structure changes in this manner. What happens in structure? The double bond O get converted to, the system get converted to OH group. Since you are using B side, so what you will get here? One double bond. Remaining everything is what? As it is. So what you are going to get here? Carbon and carbon. Clear till here? I hope you people understood this concept. Let us go with the next one, sixth one. Right, in sixth one, what happened? I'm going to use what here? I'm going to use here double bond. Okay, and here I'm going to use two carbons, and here I'm going to use double bond O. Okay, so first of all, check whether the compound is eligible or not eligible, right? So let us try to understand here whether it is eligible or not. What is the first step? So the first step is nothing but given is a functional group. Which functional group? Can I say the given is a keto functional group? Yes or no? Yes. Next, what happened here in this case? Do you have any alpha hydrogens? Yes, there is one alpha hydrogen, not two, because this carbon is surrounded by three yellow color bonds. Remaining one bond is acting as what? Hydrogen, right? Now, if that means A carbon is eligible or B carbon is eligible. Right? Can anyone answer? A is eligible or B is eligible? Only A is eligible. Okay. Suppose if A is eligible, listen. Suppose if people are thinking that if A is eligible, then what will be the resultant product? Okay. Then immediately what you should say in the product, what is the shortcut trick? Whatever the system double bond O is there, no, it get converted to what? It get converted to OH. And whatever the alpha position is there, no, that alpha position will get one double bond. Remaining will be as it is. Can say remaining will be like this. Clear till here? But can I say this structure is wrong? Can I say this structure is highly unstable? Why the structure is highly unstable? In a cyclic ring, two double bonds adjacent to each other is a highly repulsion, which makes the compound, which makes the structure as a unstable. Okay. Now what happened? That means though alpha hydrogen is present here, right? But it is not going to be eligible. Clear till here? I hope you people understood here. Right now, what happened here in this case? You people can see, right? So here, what happened in this case? Let us try to understand here in this case here, right? So let us try to understand next case. Now, what we have to do whenever you get this type of thing. Okay, so let us try to understand here. So whenever you get this type of thing, you have to check the para position. Okay, so generally this is the system, means what you will get. This is the alpha, this is the beta, and this is the, sorry, not alpha, this is the ortho, meta, and this is what? Para. Okay, so can say para has two hydrogens, right? At this time, what you have to do? You have to use the para hydrogen. Okay, if I use the para hydrogen, then what happens? Let us try to understand. Okay, right. So now what happened here is, suppose if I'm using the para hydrogen, this bond is going to be broke. Okay, this bond is going, I am going to break this bond. Okay, this bond is going to shift here, this bond is going to shift here, and this bond is going to shift on oxygen, and this hydrogen is going to shift here. So finally what you are going to get? So the upcoming structure, what are the changes you are going to see? You are going to see that the changes are, the system is going to get converted to what? OH. Okay, next, what are the things you can see? You can see there is a change in the position of the double bond. Clear till here? I hope you people understood here. Okay, right, let us go with the next one, seventh question. Right, so in the seventh question, what I'm going to do, I'm going to use one more structure. Right, so here this one and this one, here I'm going to use the double bond. Okay, now let us say, can say this is a given functional group is a ketone functional group. Yes or no? Right, so all be obviously whatever the examples till now we have learned, what we have learned, that keto form is always more stable than enol form. Okay, but the seventh example is very very important. Let us try to understand what happens in the seventh example. Right, so here what they have provided, they will provide they can say the given is a system C double bond which is the aldehyde or ketone aldehyde. Okay, so do you have alpha hydrogens? Yes, there are alpha hydrogens. Okay, that means we think that the question is eligible. Okay, but can we use these alpha hydrogens? No, we cannot use these alpha hydrogens. Reason is what just now I said, if you use this alpha hydrogen you will get two double bonds. What happened, you will get two double bonds adjacent to each other, which is highly unstable. Okay, right, now what happened here, can I say you can use the para position hydrogen. If I use a para position hydrogen, what happened, you will get this one, this will get shift here and this will get shift here. Okay, so now what happened, finally what you people are going to get here, we people are going to get the structure. What are the changes you people can see, the changes you can see where this, there is no change in this bond. Here the system get converted to what, OH, and the shifting of a double bond. Okay, can I say this is nothing but keto form, this is nothing but what, enol form. So generally what I said, whenever you see, you will say that man, keto form is always more stable than enol form. But here what happened, keto form is less stable than enol form. Very very important. The reason behind this is nothing but in enol form you can see that there is a aromaticity, there is a formation of aromatic compound. And always remember, whenever you get this stability, aromatic compound is the most stable compound among all the compounds. Clear till here? So this is the reason why keto form is less stable than enol form, in which case in seventh example. Okay, that means whenever there is a chance of forming aromatic compound, that aromatic compound is always acting as what, more stable compound than the remaining one. Clear till here? Right, so let us go for the, this is all about what, keto enol tautomerism. Okay, right, let us go few more exceptional questions. There are few exceptions, let us try to understand the exception. Okay, so what happens in exception, for example, if I take the bridge carbon, okay, bridgehead carbons, so what happened, there is a difficulty in the formation of double bond because of what, instability. For example, if I take a compound like this, okay, so total how many carbons are there in structure, 1 2 3 4 5 6, okay, and this is what, 7, right? So here in this case, okay, I will take the red one, right? So the whatever these red color carbons are, they know these red color carbons are nothing but what, bridge carbons, what you should call bridge carbon. Okay, so these are the one who is going to handle both the side, both the rings, so that's why we should call it as what, bridge carbon, right? Now what happened, suppose if I write here double bond O. Okay, I'm going to write here what, double bond O. That, can I say the given is a keto group? Yes or no? Aldehyde or ketone? Can I say given is a keto group? That means this is our uh, system, right? Its exactly next position is what, alpha. Its next position is what, alpha. Okay, now what happened to this carbon, total how many hydrogens you have, two hydrogens. Here how many hydrogens you have, one hydrogen, because each carbon can form only four bonds. Okay, now let this one is acting as A, okay, and this one is acting as B. Okay, now which hydrogens I have to use, A hydrogens or B hydrogens? Okay, always remember you cannot use the A hydrogen, because if you use the A hydrogen, then what happened, there is a formation of what, double bond. Okay, there is a formation of double bond where at the bridge position. Okay, so what, why we cannot use, because formation of double bond, okay, formation of double bond with bridge carbon, with the bridge carbon is highly unstable, is highly unstable. That means at bridge position, at bridge carbon, you cannot produce, you cannot keep any double bond, you cannot keep cation, you cannot keep anion, etc. That means you cannot do anything with the bridge carbon. Even hydrogens present at bridge carbons are non-reactive, they are never involved in the chemical reactions. Okay, now we are left out with what, B. If B is involved, B side alpha carbon is involved, then what will be the answer? So what is the change you people are going to see, right? Remember, what are the changes you can see? This double bond O system get converted to what? The double bond O system converted to OH group. This alpha carbon, what you are going to get here? One double bond. Remaining everything will be as it is. I hope you people got the clarity about this exception. Clear till here? Right, so moving to the next one. So So the next one is nothing but imine and enamine form. Okay, so let us go for the second one. So the second category is nothing but what? Enamine and imine. Sorry, imine and enamine. Okay, so what is the next one? Imine and enamine. Imine and enamine form. Okay, let us try to understand what is imine and enamine form. Okay, so first of all, what happened here? So generally in the previous case, we used to check about what? C double bond. Okay, we used to take what? C double bond O as a main system. Okay, but in case of imine and enamine, which one is acting as the main system? Here the main system is acting as what? N. Okay, C double bond N, okay, is acting as what? Our system. The only difference before and after is what? Before it was C double bond O, now it is C double bond N. Okay, since nitrogen can form total 3 bonds, here we have only 2 bonds. So what you can write here? You can write here NH. So this is the only difference. Remaining all rules are same. What are those all rules? If the system must contain, if this is a system, then system must contain alpha hydrogens. Every rule is same. The only difference between previous one and this one is what? Previous it was C double bond O, now it is what? NH2. Okay, let us try to understand here. Let us take one small example. Right, so the first example, let me take, suppose if I am taking a cyclic ring. Okay, so can I say the given is what? Double bond NH. Is it eligible for tautomerism? Yes. Who is eligible for tautomerism? Ketoenol forms, imine, enamine and nitroacid forms. Okay, now can I say this is acting as our system? Right, this is acting as what? Our system. Okay, next, its next position is what? Alpha position. Alpha position, do you have alpha hydrogens? Yes. Can I say this one is eligible for not enol, what do you say, imine and enamine tautomerism? Yes, if it is eligible, now what you are going to get here? We people are going to get, what is the changes you people are going to see? The system get converted to what? NH2. 1 minute. Yeah, so now what is the change people are going to see here? Here there is a ring as it is, instead of double bond N. So previous one we used to say what? C double bond O will changes to what? Double bond C OH. Remember, this is what we used to do the change in the previous one. In the same way, suppose if I am using A side alpha hydrogen, I am using A side. So what you people are going to get? Double bond on A side. Here you will get, the only thing difference is what? Before it was single bond, single oxygen, now you got OH. Before it was NH, now what you will get? NH2. Extra hydrogen should be added. Okay, that means in the previous case what happened? C double bond O was changed to COH. By now NH is changed to what? NH2. So this is the difference. And which one? This structure you should call it as what? Imine. Okay, and this structure we should call it as enamine. The name itself indicate en means what? Double bond. Amine means what? NH2. Clear till here? Who is more stable? Imine is more stable or enamine is more stable? Imine is more stable than enamine. Okay, so like this you can go for further examples also. I'll just give 2 to 3 questions so people can try by yourself. Okay, second question. And this time you have to find out its structure and you have to answer whether imine is greater than enamine or enamine is greater than imine. Always remember, wherever there is a aromatic compound, there that will be always acting as what? More stable. Okay, next, third example. You have to find. Clear till here? So these are 3 examples. Let us go with the next one, third category. So what is the third category here? The third category is nothing but nitro and acetone. Nitro and acetone. Clear till here? So let us try to understand nitro and acetone. So in the first case, what we learned? We learned that C double bond O was getting converted to what? Double bond C OH. Okay, this is what we have learned in the first case. Okay, but in the second case, what happened here? In the second case, you can see that, okay, C N double bond O oxygen. This is nothing but nitro group. Okay, nitro group get converted to what? C N here OH, dative bond oxygen and double bond. Okay, the everything is same. The only difference you can see that before the system was C double bond O. Now the system is what? N double bond. Okay, now later there it was convert, system got converted to what? OH. Now the system is converted to what? OH. Previously it was single bond, double bond. Here also single bond, double bond. Clear till here? Now who is eligible here? Primary nitro group or secondary nitro group or tertiary nitro group. Which nitro compounds are eligible for this compound? That two alkanes. Okay, primary nitroalkane, secondary nitroalkane, or tertiary nitroalkane. Who is eligible here? Only primary and secondary are eligible, not the tertiary. So the questions will be like, which of the following compound will not show tautomerism? You can, even nitroacid is also known as tautomerism only. Okay, or else they will ask, which of the following will not show nitroacid tautomerism? Which type of it will not show? Tertiary nitroalkane. Okay, tertiary nitroalkane will not show. Okay, for example, let us check the eligibility here. Right, for example, carbon carbon NO2. Okay, if you try to like elaborate the structure, it looks like what? Carbon carbon, nitrogen, double bond O, dative bond oxygen. First of all, what is the condition? Do you have nitro group here? Yes. Which nitro group? Can say it is a primary nitro group. Why? Nitro group attached to one carbon is called primary nitro group. Okay, nitro group attached to secondary carbon is called secondary nitro group. Nitro group attached to tertiary carbon is called tertiary nitro. Okay, I will write down here itself. What is the meaning of primary nitroalkane? Okay, what is the meaning of primary nitroalkane? NO2 attached to where? NO2 attached to primary carbon. Okay, what is the meaning of secondary nitro group? Attached to secondary carbon. What is tertiary nitro group? Attached to what? Tertiary carbon. Clear till here? Here nitro group is attached to what? Primary carbon. Eligible? Yes. Can say this is our alpha. So what is the change people are going to get? The system get converted to what? The system get converted to NOH, and here you will get double bond. Remaining everything is as it is. What is the remaining everything as it is? Carbon carbon, and here you will get dative bond oxygen. This is called nitro group. This is called acid. Clear till here? I hope you people got clarity between nitro group and acid. Done. So we'll stop the class till here.